Hi, welcome to another ClearCalcs help video. My name is Liam and today we'll be going over the seismic analysis calculator. To start, let's create a new project here. Scroll down to the loads and we'll click on seismic analysis, which is still in beta. And so the first thing you'll notice here is that the reference here is ASCE 716. We've added assumptions here below, my mistake, assumptions here below which show some of the assumptions we make in this calculator, which are very important to read, to know, and understand what we're doing with this calculator. So we can click on drop down. And so you'll notice a couple of things, including the map data, some of the key building properties, these inputs here, and this little diagram here showing the stories. So let's start one by one. Let's go through the map data first. So you'll see here there are 4 inputs, 3 of these specifically, the short period, long period, and the transition period here. These factors are in the map data for ASCE 716. Typically, you can go find this on the online tool for ASCE 7. They provide those values there for any location. For now, we're going to leave this as is, but that's typically where you'd find these values. And these are important for creating the design response spectrum in order to determine the actual loads acting on the building. Lastly, there's a site class here, which you can select from A to E. Typically, default is assumed if we're not sure what the actual site class is, provided that we do follow some assumptions. And so that is accounted for in this calculator. Next, we'll go over to the key building properties here. You'll see the risk category is hard-coded and left as 2 for now, and we're looking to implement the other categories in the future. You'll see here, this is the table for specifying the amount of stories. So let's add 2 more, and let's copy that. Perfect. So now we have a 60-foot building, each with the same seismic weight. And so the seismic weight in this case has to be specified. And for a guide here, we've included the ASCE 716 clause here, which specifies what the seismic weight is, in case assistance is needed for determining what the seismic weight is for each story. And so this can be accessed through the drop-down here, as well as any other widget which you can click to find out more information about it. For now, we'll keep them all the same weight here. We can move on. You'll see here we have 2 toggle options here, one for the custom building and one for the custom seismic force resisting system. And so this is if you potentially have a previous value on the fundamental period, or you actually know these factors here for the seismic force resisting system. For now, we'll keep it as no, and we'll have it automatically calculate. And we'll leave this force resisting system here as the light frame wood walls shear wall here. You'll notice there's a bunch of different selections here for the system, including some that fail. And so ideally you want to pick one that doesn't have any kind of X there. And so these right now are provided, and these are categories that will work typically with D and E, seismic design category buildings. So if there are any other systems you'd like for us to add, please let us know, send us an email, and we'll be happy to take a look. Next, we can move on to the seismic ground motion values. Long story short, that these factors here are based off the original factors you provided here, and ultimately calculate this design short period and design long period spectral acceleration. This in turn also calculates the seismic design category, which is D in this case, and these are very important for determining the type of analysis we can use. In this case, we've assumed to use the equivalent lateral force method. More on that in just a second. Quickly here, you'll see that there's the system properties, specifically these 3 factors. More specifically, you'll want to take a look at the R factor here, which is 6.5, and the building system height limit. And so this modification coefficient ties into the calculation for the base shear, which is the lateral force acting on the building, at the bottom of the building due to the earthquake, and which is very important for our analysis. You'll also notice here this height limit is set to 65 in feet. And so that's important, and these limits are based on ASCE and the tables associated. So say I want to add another story, we'll make it a same seismic weight, and suddenly I get a fail, shows that building is not permitted to be built or height exceeds structural limits. So obviously you'll see that the height limit is 65, that's over, we have an 80-foot building, so that's not good. Let's keep it back to 60 and let's continue on. So lastly, we have the equivalent lateral force procedure, which is essentially the procedure which determines how the base shear, this horizontal force at the base of the building, is vertically distributed to the other stories here. So you can see these fx values. So we need the building fundamental period, the total height, the total weight, and some of these other factors here. More specifically, the seismic response coefficient, which we drop down, is based off the SDS, SD1 values, as well as some other factors as well. You'll see the R factor there as well as the period. And so this CS times the weight total gives us the base shear acting on the building, which I've included up here. You'll see this is 18,200 pounds, which translates to 18.2 kips here shown on the diagram. And so this is the maximum lateral force from the estimated earthquake load that acts on the building. And so now we take some of the properties here, the seismic weight of each story, the height of each story, and we find this lateral force Fx here. You'll see 9,110 pounds, which goes to 9.11 kips. So typically you'll see the top of the building experience the most lateral force, but this ultimately varies with each weight of the story, how tall each story is, but that's the general trend going from the bottom up. You'll see each story has an associated height. We can make this 25. And if I change this to 20,000, you'll see that also updates here with 120 kip. So this is more of the interface you can use. You have the story heights, the story numbers here as well. Lastly, you'll see the story shear here, which essentially takes the base shear and horizontally distributes it using these lateral loads here. So you'll see it's as you go down the building, the story shear increases, ultimately with the first one having being equal to the base shear. And that's it. So this is the end of the video, and hopefully that helps you understand a little bit more of how we've built this calculator and how to use it. I hope you can join us in the next video where we're actually going through an actual example to see how this calculator is verified and how it actually can be used and worked. Hoping to see you there.